Okay, let's look at the unit circle again and look at some other coordinates that you can make using the second triangle we discussed earlier and the trig ratios we can get from it. If you recall, the second triangle we made from taking an equilateral triangle and chopping it in half. Okay, we had sides of 1, 2 and root 3, and the angles were 60 degrees in this corner, that's pi over 3, and 30 degrees in this corner, which is pi over 6. Now what I'm going to do is this. Again, what I want to do is make the hypotenuse a length of 1. So I want to make this side 1. So how can I scale this triangle down and make that side 1? I'd have to divide each side by 2, right, to scale it down, because 2 divided by 2 is 1. So I'd have to divide each side by 2, so I'll get a half here, and I'll get a root 3 over 2. Okay, and then the angles in the corner don't change. This is still pi over 3, and this is still pi over 6. Okay, so when you scale something down, it doesn't change the angles. So this is just a smaller version of that triangle there. Okay, now these coordinates on this on the unit circle, okay, are all made from this blue triangle here. They're all made from that particular blue triangle. And let's look at the first particular coordinate and where it comes from. Okay, so take this coordinate here, and if you see, I can make a triangle by going along there, across and up. Okay, that would be my 90 degrees. This would be my 1. Okay, but if you look at this triangle, it's like taking this 90 degrees, okay, or pi over 2, and chopping it up into 3 equal bits. So this angle here would be pi over 6. Okay, that'd be pi over 6. So you got your pi over 6 and your hypotenuse is 1. So this distance here would be the longer side here on this triangle here would be the. So I'd go across root 3 over 2 to get to this point. Okay, root 3 over 2, and then up a half, right? Up a half to get to this particular coordinate. So that's why this coordinate is root 3 over 2 and a half. Okay, just by going along and up. Okay, now let's go through all the coordinates actually, just so we can just see where they all come from. Right, look at this triangle here. So let's look at this coordinate here, sorry. If I make a right angle triangle like this, okay, and again it's the same right angle triangle, so this angle would be the pi over 3, this large angle would be pi over 3, okay, and that little inside angle would be the pi over 6, and that would be the 1. Okay, so what would this distance be? That would be the shorter distance here, would be a half. Okay, so I'd go across a half. And then what would be the side going up? Well, it would be root 3 over 2, so it's root 3 over 2. Again, the angle there is pi over 3. But what I want to just look at is this. I did say to you that these 3 angles are identical to each other just a moment ago. As in, if I take pi over 2, which is 90 degrees, and divide it into 3 bits, divided by 3, I get pi over 6. So each one of these orange bits is pi over 6. Okay, the pi over 6. We're going to come to that, back to that in a moment. Well, actually, you know what? These are all of these little bits are pi over 6. Okay, but I've got 2 of them here. Okay, if I times that by 2, I get pi over 3, right? So that's why this red angle is pi over 3, but each one of these little bits is pi over 6. So that's where that coordinates come from. Okay, and the same thing, I can do it for this coordinate here as well. So let me do it for this coordinate. Okay, so this is the right angle triangle, the blue one, but back to front. Okay, it's a mirror of the one I just rubbed out here actually. So this angle would be pi over 3. Okay, and then there would be your 90, there would be your 1. But what would I need to go along and up to get to that coordinate? I'd need to go minus a half along, and then root 3 over 2 up to get to this coordinate. Okay, and all the other coordinates are made from this one triangle. Okay, so this one as well. Okay, there's a triangle to make that one. Okay, you can see I'm going along minus root 3 over 2 and then up a half to get to this point. And then same thing here, I'm going to get to this coordinate, I'm going minus root 3 over 2 to get here, and then down minus a half. And this coordinate, I'm going along minus a half, let me do it in red. I'm going along minus a half to get to here, and then I'm going down minus root 3 over 2 to get to this coordinate. To get to this one, I'm going along a half, that's why this is a positive half, and then down minus root 3 over 2 to get to here, and then this one I'm going positive root 3 over 2 to get to this point, and down a half, minus a half to get to here, and there's a triangle that makes that last one there. So all these coordinates are made up from just this one triangle. Well, what does it help us do? Okay, like I said to you that each one of these little bits here, okay, each one of these little bits is 30 degrees, yeah, or pi over 6. Okay, so you can use degrees if you want to. This is pi over 6. They're all pi over 6. Okay, these are all pi over 6. But if someone said to you, right, can you work out for me, please, without a calculator, can you work out the following? Let me move it down a little bit. It's got space for it. Can you work out the following? Can you work out cos of, let me make something up, 4 pi over 6. Okay, I should really simplify that fraction, but never mind. 4 pi over 6. What's that without a calculator? Okay, so starting from the origin, okay, well, we need to find the angle 4 pi over 6. So we've got 4 lots of pi over 6. So we've got 1, 2, 3, 4. So this is the angle theta, right? That's the angle theta. That's 4 pi over 6. That's that angle. So it's related to do with this coordinate. Remember, we always measure from the x-axis going anti-clockwise. So it's to do with this coordinate. And if you recall, cos of the angle is the x component, sine of the angle is the y component. So what is cos of the angle? Well, it's this x component here. It's minus a half. And if you check it out on the calculator, if you check it out, let's do that. Cos of 4, okay, I need to just make sure it's in radians. Yeah, we're working in radians for now. Get the fraction at 4 pi over 6, press enter, we get minus a half, just like we predicted. Or you could work backwards. If someone said to you, sine of something equals, I don't know, minus a half, what angle could theta be? What angle could it potentially be? So again, like I said to you, the sine of the angle represents the y component. But if you remember this circle, you'll recognize that minus a half is to do with this circle. So we're looking for y components which are minus a half. So that is not minus a half, nor is that one. Nope, nope. This one, right? Okay, so there's one. And there's the other one. There's the other one that's got minus a half as the y component, right? So we're looking at these two coordinates. So starting from the x-axis, going around in an anti-clockwise direction, that's your theta. There's one of them. We could have more than one answer. So what is that angle? That gives us sine of minus a half. Okay, so sorry, sine of it gives us minus a half. 1, 2, 3, 4, 5, 6, 7. All right, 7 pi over 6. Okay, if you check that out, well, let's just do it. Trig, and the fraction 7 pi over 6, get minus a half. There we go, that works. Okay, and the other one, okay, the other one is all the way around here. So up to here is 7, so it's 8, 9, 10, 11. 11 pi over 6. Okay, that's another answer that could be. If we check it out, let's just make sure it gives us the same thing. 11 pi over 6. Press enter, get minus a half as well. So there are your two answers, two potential answers for theta. So knowing this is going to help us a lot. So you need to try and somehow learn these two circles and these key points. Kind of crucial for our next bit. So make sure you get them in your heads.